Welcome to this explainer. Today, we're doing a highly technical deep dive into something that's literally the hidden foundation of modern enterprise data centers: dual-layered time synchronization. For network engineers and enterprise architects, understanding the structural shift from basic network timing to high-accuracy distributed time is no longer just optional, it's absolutely crucial. So, let's dive right in.
Here's how we're breaking down the architecture today. First, the modern data center mandate. Then we'll look at NTP as a reliable foundation, followed by PTP for sub-nanosecond precision. After that, we'll see how they form a complementary architecture, and we'll wrap things up with the future of time.
All right, part one, the modern data center mandate. It's time to completely dismantle the assumption that time is just some background operational process.
When you're dealing with the sheer complexity of modern data centers, relying on legacy internet-based time, that's just no longer a viable engineering decision. Literally every single workload running on your servers relies on precise timing. It is the definitive structural glue that holds distributed enterprise infrastructure together.
And today, engineers are facing this fascinating dual mandate. On one hand, you've got absolute security. Zero-trust environments demand verifiable internal cryptographic authentication. You just can't implicitly trust external sources anymore. On the other hand, you have absolute precision. We're talking about a massive structural shift from measuring things in milliseconds all the way down to sub-100 nanoseconds to actually drive ultra-high-speed telemetry and compute.
So let's move to Section 2, NTP, the reliable foundation. This is the protocol that really anchors the security side of that mandate. Now, I know what some of you might be thinking, but no, Network Time Protocol, or NTP, is far from obsolete. It's the unbreakable backbone handling your daily IT operations, giving you accurate, secure, and reliable time-of-day synchronization right down to the sub-millisecond level. For your general servers, routers operating from Stratum 2 down, and enterprise switches, NTP is the absolute workhorse that improves business operations across the board.
To get specific, your critical enterprise applications absolutely depend on it. Think about Kerberos authentication. It requires incredibly tight time sync to prevent replay attacks, or Windows directory services, regulatory compliance, and audit trails. Without reliable NTP, you literally can't verify access rights, and you lose that non-repudiation that's strictly required for enterprise security.
When things go wrong and an incident occurs, your SIM dashboards and forensic tools rely entirely on sub-millisecond timestamps in your trace logs. NTP makes sure that distributed events across totally disparate machines can be reliably correlated. It's a real game changer for drastically speeding up fault diagnosis and incident response. All right, Section 3, PTP, sub-nanosecond precision. Let's talk about what happens when we move way beyond millisecond accuracy at the network edge.
As data centers evolve, new applications are pushing hardware to its absolute physical limits. Just to put this into perspective, in a single nanosecond, light travels barely 1 foot. That extreme physical reality forces a structural shift, where a whole new standard of timing accuracy is demanded. Enter Precision Time Protocol, or PTP. It pushes synchronization into the sub-microsecond and even sub-nanosecond realm for those highly latency-sensitive compute workloads.
So what kind of environments actually need this extreme level of sync? Well, first, high-frequency trading, where mere nanoseconds literally define your competitive advantage. Second, ultra-low latency switching environments that have to completely minimize jitter and delay. Third, distributed databases and big data analytics that require insanely precise event ordering. And finally, modern AI and image processing workloads.
It's a really interesting contrast when you look at these modern workloads. Over in the financial sector, tomorrow's high-frequency trade is won on today's ultra-fast synchronization. Meanwhile, within the physical architecture of AI, you've got distributed GPU clusters that absolutely rely on precise timing to sync up for image processing and rendering. Without PTP, these clusters just cannot sync their distributed workloads efficiently.
Moving on to Section 4, a complementary timing architecture. Let's look at synthesizing both of these protocols for your data center topology.
The main takeaway here is that in modern enterprise data centers, NTP and PTP are not competing technologies. Not at all. They serve entirely distinct yet equally vital engineering purposes. NTP is giving you highly scalable, robust, and reliable synchronization for general IT systems, handling all your security and logs. PTP, conversely, swoops in to deliver the absolute high precision required for real-time, latency-sensitive applications.
So when you put it all together, a complete hierarchical timing architecture spans 3 distinct functional zones. Zone 1 operates in milliseconds, using legacy NTP for things like directory services and basic log recording. Moving inward to Zone 2, we hit the microsecond scale, which is perfect for distributed databases and cloud media workloads. And finally, right at the edge in Zone 3, PTP operates in tens to hundreds of nanoseconds to support 5G ORN, ultra-fast financial trading, and AI rendering. Together, this hybrid network gives you massive scalability and absolute precision.
Which brings us to our final part, Section 5, the future of time, and what this means for global connectivity.
As edge computing and 5G networks continue to explode, accurate timing has truly become the distributed computing glue. The future requires high-accuracy time transfer directly between data centers over optical networks. It demands seamless, high-speed integration to future-proof these massive multi-million-dollar data facilities against the intense latency demands of tomorrow's AI networks.
As network engineers and architects, we are at a critical turning point. If you evaluate your current network architecture, you'll likely find that operating without a dual-mandate timing solution is introducing some serious operational friction and critical security vulnerabilities across your infrastructure. The demands of sub-nanosecond compute workloads and zero-trust security, they aren't just on the horizon anymore, they're already here. Time synchronization has totally transcended being just a background op. It's a strategic enabler of enterprise innovation. From milliseconds to nanoseconds, from your basic forensic logs, all the way up to distributed GPU clusters and ultra-low latency switches, accurate time is the definitive foundation, keeping the modern digital world in sync. So, I'll leave you with this critical challenge. If your multi-million-dollar infrastructure is still relying on implicitly trusted legacy internet time, are you truly prepared to secure the nanosecond workloads of tomorrow? Thanks for joining me on this explainer, and I'll catch you in the next one.